All right, I think most of like the participants already came in. Shall we start now? Okay, I will start now. And today webinars on the Supermicro's cutting edge system designed and optimized for a wide range of compute workloads. So, during the presentations, if you have any questions, just feel free to drop them anytime in the chat box, or questions will be collected and our guest speakers will address during the dedicated Q&A sessions at the end of the presentations. So good afternoon, everyone, and very warm welcome to the PSTC Academy webinar. My name is Atapon Wichadit, and it's my pleasure to be your moderator for the today event. We are thrilled to have you all join us for what promises to be highly informative and engaging session. Today we are devolving to a topic that is at the very heart of a modern computing and data-driven innovation. Supermicro's cutting-edge systems designed and optimized for a wide range of compute workloads. In our increasingly digital world, the demand for the powerful and efficient computing has never been higher. Whether you are in the field of AI, machine learning, data analytics, or high-performance computing, the infrastructure you use in the foundation of your success. Supermicro has long been a leader in this space, known for their innovation in server technology. They are built a reputation for creating systems that are not just powerful, but also meticulously optimized to meet the specific and diverse needs of today's more challenging workloads. We will be exploring how this design philosophy translate into tangible benefits for varieties of industries. We are incredibly fortunate to have two distinguished experts with us today who will shed light on these fascinating subjects. First, we have Mr. Wen Yushen, the esteemed Chief Executive of Infinitix. Mr. Chen brings a wealth of experience and a unique perspective on integrating these advanced technologies. Mr. Chen, thank you so much for being with us today. And second, we are joined by Mr. Si Liang, the Senior Business Development Manager from Supermicro Computer. Mr. Liang is an expert on the various systems we'll be discussing today and will provide us with an in-depth look at their capabilities. Mr. Liang, it is an honor to have you here today as well. Over the next hours, our speakers will walk us through the design principles, technological advancements, and real-world applications of Supermicro innovative solutions. They will help us understand what makes this system so effective at handling everything from complex scientific simulations to mission critical business applications. So without any further ado, let's begin. I would like to hand the virtual stage over to our first speaker, Mr. Wen Yushen for Infinitix Company. Mr. Chen, the floor is yours now. Thank you.
Thank you. Hello, everyone. Good afternoon. I'm Wenyi Chen from Infinitics. I'm the CEO of Infinitics. Today, I will share our experience on the AI data center with a management platform. First, I would like to introduce Infinitics. Infinitics is a software company in Taiwan. We develop some resources management platform like a hybrid cloud management or GPU resources management, AI development and operations platform for our customers. And we based on Taiwan, but we have some subsidiary in Japan, China, and Singapore. So we are expanding our business in Asia market. Infinitics is a global-wide partner of NVIDIA. We can provide many experience, knowledge to our customer, help them to build and design an AI data center, and also can help them to develop some AI application on like a ML ops platform. So we have some different industry customer in the Asia market, including semiconductors, healthcare, medical, finance company, also including many research center like universities and some kind of the supercomputing centers. So we can share our experience to our customer. Also, I would like to share our experience on this moment to you all. And we have some major shareholder like Delta Electronic, Campbell Computers, and they invest Infinities to help our business to acquire more and more data center customers and more and more major bigger company like IPO company, semiconductor companies. So we share our experience and our product to our customers, and also share our experience to our shareholders together. And you can see this page. We are expanding our business in Asia market. So we have major distributor in Japan, Taiwan, and Thailand, Malaysia, and China. Also, we have distributors in US, and we cooperate with many server makers like Supermicro or some kind of AMD server maker like Compel, MyTech. And we also cooperate with the NVIDIA and the AMD. We can help them to manage GPU resources for their customer to use GPU for more efficiency. If you would like to understand how to build and design a data center, you just not only focus on server, you also have to focus on storage. So we also cooperate with many storage partners like MinIO, Dell, or like high performance storage company, DDN, Vest Data, or Weka. So if you rely on the computing and storage, you also have to onboarding some AI applications. So we also cooperate with our AI ecosystem partner. We call AI ISV partners. So you can deploy their application on our product like Pegatron's AI platform, like Power Arena for computer vision, to help their customer for different. And we also provide our product to our customer, not only share our experience and the knowledge. So our major product is called AI Stack. AI is a AI infrastructure management platform. Also help our customer to manage GPU resources. So you can imagine that you can manage the GPU resources on AI Stack, and also you can deploy or develop an AI application on AI Stack. So if you are focusing on AI industry, maybe you will understand how to train or how to fine-tune your AI model. But in the AI industry, not only training the model, so also including deploy the inferencing model, and leverage the generative AI, deploy the AI model, and fine-tune the AI model. Also, if you have many AI models, maybe you would like to combine them and for do something automatically. So you will have to understand generative AI, agentic AI. So for this fourth stage, you have to leverage the GPU resources and the AI infrastructure. But this is very different on each stage. For example, you have to understand how to training your model. You have to leverage more and more GPU together. And but sometimes you just doing the fine tune of the model. So you maybe not need to more GPU. You just need to 1 or 2 GPU. So how to leverage the GPU on this stage is very important. But if you would like to deploy the inference model on a microservice, sometimes you don't need to deploy the inferencing model on 1 GPU. Some model is very small. So you should separate the GPU as a many GPU slice for deploy many inferencing model on 1 GPU. So you have to leverage the GPU efficiency on this stage. And if you move to deploy generative AI, sometimes almostly generative AI is very big. The model is very big. So you should think about how to deploy the big model on the GPU. Also, you how to think about develop and training the model on the GPU clusters. So this is a very important thing that you have to leverage the GPU resources for huge computing power needs. And the other stage, if you move to agentic AI, you have to leverage many models together. So it's very difficult to manage your GPU because you deploy the many models on the one time. So you have to leverage the many model for many GPU for one model. Also, you have to leverage many models on one GPU. So GPU resources and the AI infrastructure management is very important in the AI area. So we provide our product for our customer to help them manage the hardware, including different type of GPU like NVIDIA GPU and AMD GPU. Also manage different type of storage for AI development, AI deployment, also store the tenant data for the clear data, labeling data used. So if you have to leverage the hardware resources and manage them very well, you have a provide a platform. You can deploy the platform on your hand. Also, you can leverage like some kind of software like AI stack to help you manage the hardware layer. And if you provide a hardware, you should to think about how to manage them for quota management control, permission control, or some kind of the monitoring for health check, for power efficiency. So the orchestration layer is very important for manage the hardware and deploy the required from users. So as a leverage Kubernetes together, we develop some device plugin, some resources scheduler in Kubernetes, and we also leverage Kubernetes API for providing the user platform, user portal, and operation portal to our customers. So the application layer is about how can provide a portal for user do anything by themselves. They can provision the development tools. They also can train the model and monitor the model health. Also, they can deploy some application by themselves, like deploy Llama 3 with OLlama together. So they can download and deploy any kind of model on user portal. And also, if you have to manage the AI data center, the challenge is about the many kind of the knowledge you have to learn from operators. So if a software stack like ASA can provide a operation portal for them, they don't need to understand more low layer knowledge, like how to operate Kubernetes, how to deploy the cluster. They don't need to understand. They just looking to operator portal and use a management function for a different purpose, like manage the policy, manage the quota, manage the matrix of a health track. So they don't need to understand more hard skill for themselves. They just need to understand how to operate the policy management in the portal. So we provide a whole stack from hardware orchestration and application layer as a one portal for our customers. And ASA provide some core technology knowledge for our customers. But the major thing is about GPU resources management and AI machine learning or deep learning operations. So we, through the AI stack, to provide the different environment for development or deployment on AI. So by user, they can provision any kind of the environment if they need on a development stage or deployment stage. They can develop different project and provision different environment by themselves. And if they operate their need on the portal, as they provide the provisioning technology on our platform, so we can automatically to execute provision process from provision hardware resources, provision the storage space, provision the permission, provision the policy by automatically. And we ensure the resources can be isolated for different project and the different users. So they have the they can ensure their data policy, data protection, and they can ensure the resources for their use. And we also provide some technology to manage GPU resources for more efficiency. So we have 3 core technology on AI stack. One is about the GPU partitioning. We can separate many GPU stacks on one GPU by user needs. For example, if the model requires 4 gigabytes, the user can separate the 4 gigabyte on one slice, GPU slice, and the other one requires 8 gigabyte for a small language model. The user also can provision the 8 gigabyte GPU slice on one GPU by themselves. So this is our first core technology that's about the GPU partitioning. And the other one is about how to combine many GPU on one GPU for more and more GPU computing power to execute some like model training. So we aggregate many GPU together on one servers. On one server, your customer can aggregate 2, 3, or 8 GPU together, and we find the good topology on the GPU link, like through the NV link, so we can ensure the efficiency of GPU aggregation together. And the third core technology is about provision the HPC and provision the distributed learning environment on the same GPU cluster. For example, if you require for GPU containers, and also you require 4 node for HPC. In the traditional way, you have to separate 2 clusters, one for AI workload, the other one for HPC. But we have this core technology is about we provision anything, provision AI GPU containers, provision them for HPC cluster, and also provision some the distributed learning cluster like using Harvard, using this speed. So we provision anything on one and same cluster. So you don't need to prepare different cluster, and you don't care about the efficiency on different cluster. As I can find a good efficiency for deploying the cluster of different needs. And we also provide the other good application for our end customer, that if they not only deploy AI model, they deploy AI model and also deploy AI application together. The AI application including web-based user interface, including the large language model, including the database, including the like message queue together. So we provide as a RCS for our customer. They can deploy them on the same time, and also like deploy as one application in the one time. So it's very good for deploy any kind of the generative AI. For example, our customer leverage OLAMA or VLM to provide AI chatbot. The application is very difficult to deploy, but they use a RCS function. They can deploy the huge application very easier. So if you are looking about design and build a high performance and AI computing data center, you not only to design the GPU, you have to consider about how to deploy GPU and leverage the storage. But if you provide the storage, not only provide a high-speed storage for put the data into the GPU cluster, you also need to consider about how to store the tenant's data in the cheaper storage cluster. And if they clear the data and put the data for training, how to put the data from the tenant storage to high-speed storage and to GPU cluster. So you have to design the GPU, design the computing topology, design the storage, and design the storage topology together. But you have to consider the other way. It's about how to manage them, how to manage GPU cluster, and how to manage the storage, put the storage data to GPU. So you have to prepare some kind of orchestration layers, some kind of platform of management. So management node is very important on the AI data center. If you provide a data center design topology to NVIDIA, they also ask you which kind of the management platform you use. So if you think about design a AI data center, so management also very important with the GPU cluster and the storage cluster. But if you prepare the data center and do the business of the AI data center, you have faced your end customers. So how to acquire your customer very easy and quickly? You have to provide your service, GPU as a service on internet. So you also require to understand how to prepare some security, network security, data security for your tenant, for your end customers. So we also provide our customer to leverage AI state, provide GPU as a service, provide a token as a service, and model as a service business to AI data center. So we are not only serve end customer like a large enterprise, we also serve our customer like a AI data center. If you are looking for some kind of management platform of AI infrastructure or GPU resources management, AI can help you to increase your GPU utilization from 30% to 90%. We use our core technology to separate many GPU slices on one GPU. For example, we can slice 80 GPU slices on one H100 GPU. So we can increase the workload execution from 1 to 10 times, more than 10 times. Also, we provision the environment, not only for model training, also for inferencing microservice. We provision the environment from 2 weeks to 1 minute. So you can easily deploy any kind of the application. You can easily provision the Slurm cluster on 1 minute, not for 2 weeks. So we increase the ROI of AI from more than 10 times. So that's why we acquire many kind of the customer with us. So you can see this use case, we have many major enterprise use ASA, not only in enterprise use, also they are provide enterprise-wide data center for their supply chain partners or for their end customers together. So including semiconductor industry, manufacturing, financial service company. So if you have some required like how to build, how to deploy AI data center, how to manage the AI GPU computing power together and deploy the AI application, you can contact us and we can provide our experience to you. Okay, thank you. Any question?
Thank you so much, Mr. Chen, for sharing that powerful overview. Now, let's get into the deep tech side of things with Mr. Liang from Supermicro. Yeah, the floor for you, Mr. Liang.
Yes, let me share my screen. Okay. Okay, good. Okay, thanks for Wenyu to giving us an excellent intro to the software side. Now, let's check out the hardware. And good afternoon, everyone. This is Xi Liang from Supermicro. Welcome to the webinar. Before we dive into the exciting world of GPU systems, let me start with a quick introduction to Supermicro. Supermicro founded in 1993 and headquartered in San Jose, California. It's a global technology leader committed to delivering first-to-market innovation of enterprise, cloud, AI, networks, and 5G telco, edge IT infrastructures. That really sets Supermicro apart is the commitment to the innovation, customization, and sustainability. We design and manufacture a wide range of server systems, from compact edge solution to the powerful GPU-optimized platforms. So today, as we explore Supermicro's GPU server offerings, we are really looking at the result of decades of engineering expertise, deep industry collaboration, and forward-looking approach to data center infrastructures. So as we know, the demand for AI computing has absolutely exploded over the past few years. We also see that AI has become a buzzword. Everyone's talking about it, but we need to understand that there are so many types of AI. For example, generative AI like ChatGPT, and predictable AI like machine learning for forecasting or classification. Each type of AI serves different use case and is adapted by different industries. That means the software and hardware required to support these workloads can vary significantly. I'm proud to say that today Supermicro offers one of the broadest portfolio of AI optimized server in the world. If you have visited our website, you might have noticed that we have more than 80 official released models just in the GPU server category alone. But with so many options, it's no surprise that customers often ask me, which one should I choose? So today, I'd like to help answer that question. I will walk you through a few key Supermicro GPU server models that are expected to be the mainstream choice for AI data center in the second half of the year. We will also take a look at how Supermicro provides end-to-end solution from servers to data center infrastructure to help you build a future-ready AI computer center. So I'm not sure if you have the same experience, but it's happened to me all the time. Customer come to ask, oh, Mr. Liang, do you have any server with 8 B200 GPUs? So it's a very common question, whether it is an enterprise customer or a CSP, unless they have a strong in-house technical team. Most customers start their GPU server selection by focusing on GPU itself. So today, let's follow that same logic and begin with looking at the GPUs currently available on the market. Due to time constraint, I will only focus on the most widely adopted one, those from NVIDIA, which dominated the AI data center space. Of course, Supermicro also have support AMD and Intel AI optimized platforms. So this table is based on NVIDIA's official data center platform line cards. These are the mainstream GPUs that NVIDIA recommends for different type of AI workloads. The color blocks indicate how suitable each GPU is for a given application. The darker the color, the stronger the recommendation. For today's session, I will be focusing on a few best-selling GPUs in our region. So let's start with the Hopper series GPUs. Over the past 2 years, the H100 has been one of the most talked about GPUs in the AI world. It came in 2 main form factors. First, the PCIe version, which looks like just like a standard PCIe card, great for flexibility and scalability. You can start with just a few GPUs and scale up as your workload grows. The second, SXM, which is used in a high density system like NVIDIA's DGX or our HGX platform. In this setup, 4 or 8 H100 GPUs are mounted on a single GPU board with high-speed interconnects between them and much faster or more efficient than the PCIe. This design is ideal for large-scale training workloads that requires tight GPU to GPU communication. However, both these H100 variants have officially entered end of life early this year. There's also a third product in the H100 family, the GH200 or Grace Hopper superchip. This is the unique architecture where the Grace CPU and H100 Hopper, the Grace CPU and H100 Hopper GPU are packaged together on the same module. So now stepping in to replace the H100 is the H200. It features faster and larger high bandwidth memory, higher performance, and of course, higher power consumption up to 600 watts per GPU. Like the H100, it comes in both PCIe and SXM version. And when it comes to PCIe GPUs, one of the key questions is how many GPUs can I fit into a single server? That's why Supermicro offers a wide range of form factors from 2U to 5U, depends on your density and thermal requirements. And just a quick note here, the server I'm showing today are just the most commonly requested model. The H200 NVL PCIe GPU, for example, can be paired with a wide variety of servers. So now looking at the far right of the slide, we have the SXM-based HGX system. Supermicro offers both 4 GPU and 8 GPU configurations, and each in air-cooled and liquid-cooled options. Now, let's talk about NVIDIA's latest generation, the Blackwell series. In the commercial GPU lineup, the key product include the B200, GB200, and RTX Pro 6000 server edition. So for today's session, I only go into GB200 in detail. It's a powerful solution, but due to its target customer profile, it may not have a focus. The B200 is currently one of the most in-demand GPUs. It is only available in SXM form factor, and it comes as a fixed 8 GPU board. Now, looking at the server side, you will see I have listed several model names here. That's because these systems use different CPUs, ranging from different generation of Intel Xeon Scalable to AMD, both air-cooled and liquid-cooled options. Speaking of cooling, B200 is not the last generation to support air cooling. In fact, the upcoming B300 still support air cooling, but might be the last generation. So if you are planning to build a new data center, now is the great time to start seriously considering liquid cooling infrastructure. Finally, Let's take a look at the RTX Pro 6000 Server Edition. Just from the name, you might notice a few things. First, it's part of the RTX family, which means it's designed not just for AI workload, but also for graphic acceleration. This makes it ideal for enterprise edge data centers such as small to medium-sized businesses running private AI applications, digital twins, or other visual AI use cases. Also, the server edition implies there are other versions, and yes, NVIDIA has also released the 2 workstation editions, which are optimized for desktop environments and not suitable for data centers. The same as H200 NVL PCIe GPU, the Pro 6000 is also dual slot, 600 watts PCIe GPU. That means, in theory, any server that supports the H200 NVL should also be compatible with the Pro 6000. So far, we have looked at today's mainstream data center GPUs from a GPU-centric perspective, which, to be honest, also help us give our partner NVIDIA a bit of well-deserved spotlight. Along the way, we touched briefly on the corresponding server platform. Now, let's switch gear and look at things from server-centric perspective, focusing on Supermicro's GPU server portfolio. And let's start with the GH200 Superchip and the MGX systems. So what kind of application actually need the GH200? And why not just use H200 instead? Let me share a few thoughts based on my experience. The GH200 has a lot of impressive features. You can check out NVIDIA website for a full list. But to save time, I will highlight just 2 key points that really set its apart. First, the CPU and the GPU are integrated into a single superchip, which enables ultra-high bandwidth communication between the two. This architecture offers significantly better CPU to GPU interconnect performance compared to traditional setups. And because of each GH200 models has a 1-to-1 ratio of CPU to GPU, it's designed for balanced compute workload, making it especially suitable for high-performance computing applications where both CPU and GPUs are heavily utilized. Second, the GH200 features shared memory between the CPU and the GPU, up to 624 gigabytes of unified memory. This means both CPU and GPU can directly access the same memory pool, which improves the memory efficiency and allow the large AI models to be loaded and processed. So if your workload involves large-scale simulations, scientific computing, or AI model that requires tight CPU to GPU collaboration, the GH200 is a game changer. It's not just about the raw GPU power, it's about architectural synergy. Based on NVIDIA GH200 Superchip, Supermicro offers a range of MGX systems designed to meet the needs for different projects and workloads. We provide both 1U and 2U form factor, and each form factor comes with options for single or dual GH200 configurations, both air-cooled or liquid-cooled options. Every MGX server includes built-in storage, typically 8 hot-swappable E1.S NVMe drives for fast local data access. In addition, there are 2 M.2 NVMe drives for operating system. It also supports NVIDIA's Connect X7 networking card and Bluetooth 3 DPUs, enabling high-speed 400G connectivity to external all-flash storage. This allows GPU to direct access external NVMe drives, bypassing traditional network bottlenecks and significantly improving data throughput. Now, let's move on to the next generation in the Hopper lineup, the H200 series. H200-based server have 2 main types, PCIe GPU server and HGX GPU servers. Each category serves different needs, and in the next few slides, I will walk you through the key models, configurations, and use case for both types. Here we are looking at Supermicro's PCIe GPU server that supports the H200 NVL. As shown in the top left, H200 PCIe is a dual slot card 600 watt GPU. We offer different server model depending on how many GPUs you plan to install. For example, if you are starting with 2 GPUs, a 2U MGX PCIe GPU system is a great fit. For 4 GPUs, if you want to move up to a 3U PCIe GPU system, if you don't require the redundant power supplies, the 2U and 3U servers can support even double the GPU counts. If you do need full GPU capacity and power redundancy, we recommend our 4U MGX PCIe GPU systems or the 5U PCIe GPU systems. These platforms are designed to handle 8 H200 GPUs while maintaining the robust power and thermal management. This brings me to a key point. The PCIe GPU offers excellent scalability. You can start small, say with 2 GPUs, and scale up as your workload grows. But it's crucial to plan ahead. Ask yourself, what's the maximum number of GPUs I might need in the future? That answer will help you choose the right server, size, and power configuration from the beginning. Shift from PCIe to SXM-based HGX system, as shown in the top left, the H200 SXM configuration mounts 8 GPUs on a single GPU board. In addition, Supermicro also offers a 4 GPU HGX systems, give you a flexibility depending on your workload and budget. We offer 2 main configurations, a 4U liquid-cooled system and 8U air-cooled system. Both support Intel and AMD CPU. For networking, this system can be equipped with up to 8 400G InfiniBand that enables high-speed GPU-to-GPU communication across multiple servers, allowing you to scale out your AI workload efficiently. This is the same architecture used in many large-scale AI factory deployments, where thousands of HGX GPU systems are interconnected to form massive compute cluster. So stay tuned, there are a lot of more exciting stuff coming up. All right, now let's move into the next generation Blackwell architecture solution. Let's take a moment to compare it with the Hopper. As you may recall, Hopper includes GPUs like H100, H200, which have already made a huge impact in AI and HPC workloads. But with the growing complexity of models and in the increasing demand for compute and memory bandwidth, NVIDIA has introduced Blackwell as the next big leap forward. Supermicro is again the first to introduce its Blackwell GPU servers. Let's take a closer look. Currently, the official released GPUs based on Blackwell architecture include the B200 designed for the large-scale AI factory, the GB200 aimed at hyperscale deployments, which we won't cover today, and the RTX Pro 6000 tailored for the enterprise users. Supermicro was the first to launch B200 GPU servers. You will see our 4U liquid-cooled HGX B200 system and 10U air-cooled. One key difference from the Hopper HGX system is that Blackwell HGX only comes with 8 GPU configuration. There's no 4 GPU board option. Based on publicly available information, the B200 delivers 15 times higher the inference performance than H200 and triple its training performance. But the cost of the complete server is just around 30% higher than H200 server. As for CPUs, we continue to support both Intel and AMD platform. This is just a sample of what we offer. If you look at our website, you will see much broader portfolio of B200 HGX systems. Let's take a closer look at one of our flagship systems, the liquid-cooled 4U HGX B200 system. This server featured a dual CPU architecture, and you have multiple CPU options to choose from Intel and AMD. On the networking side, same as H200 HGX, the B200 HGX supports 1-to-1 GPU to NIC mapping with 400G InfiniBand. In addition, it supports 2 BlueField 3 DPU cards from NVIDIA. This DPUs allows your GPU servers to connect directly to external storage, enabling direct data access from massive external dataset, a huge advantage for AI workload that rely on fast, scalable I/O. Now, let's talk about cooling. This server uses direct-to-chip liquid cooling, or DLC for short. Just a quick note, the image shows here is just one of our DLC server models. We also offer a variant called DLC2. What's the difference between DLC and DLC2? Well, we will cover it in more detail when we get to the data center building block solution section later in this presentation. Well, what to consider when installing GPU server into a rack? There are a few key factors you need to evaluate: power consumption of each server, weight and physical dimensions, and how many servers you can safely and efficiently fit into a single rack. This decision needs to align with your rack's power supply capacity and your data center's floor load bearing limit. And if you are using liquid cooling, you also need to consider compatibility with CDU, a coolant distribution unit, a very important element in liquid cooling rack to push forward your GPU density per rack. I will talk more detail later in the liquid cooling section. This 48U rack in the picture, you can deploy 8 B200 HGX systems, totally 64 B200 GPUs, which together consume around 110 kilowatts. Now, let's take a step further. What happens when we start to combine multiple racks? To build a full-scale GPU supercluster, we need more than the server. We also need different levels and types of switch, power shelves, etc. And of course, a complex cabling setup for to connect all the network elements together. Once everything is wired and configured, congratulations, you have just built a GPU supercluster. And this is exactly how modern AI factories are constructed, by combining multiple clusters like this into a scalable, high-performance infrastructure. Here are two typical examples of liquid-cooled supercluster configurations. On the left, we have the most common setup: 4 48U racks with 32 HGX servers and 256 B200 GPUs. On the right hand, we have a high-density configuration using 8 52U racks, and we deployed 96 HGX servers, totally 768 B200 GPUs. That's an incredible amount of computing power in a very compact footprint. Now that we have covered the liquid-cooled HGX B200, let's take a look at its big brother, the air-cooled HGX B200 8 GPU servers. This system is a massive 10U in height. It's mainly due to the large air cooling heatsink required to manage the thermal output of 8 600-watt GPUs. We also offer a more compact 8U air-cooled HGX option with certain lower TDP CPUs. Aside from the physical side, there is no major difference in spec between the air-cooled and liquid-cooled version. So if your data center isn't ready for liquid cooling yet, or if you prefer a more traditional setup, the air-cooled HGX B200 is a solid alternative with nearly identical performance. One major difference that comes very clear when you start to installing them into the rack, the GPU density per rack. We talk about in a standard 48U rack, you can fit 8 servers with total of 64 B200 GPUs if you use liquid-cooled HGX. Now, let's look at the air-cooled HGX. Because of the overall height of the system, you can only fit 4 servers into the same 48U rack. That's cut your GPU density in half, down to just 32 B200 GPU per rack. So while air cooling may be easier to deploy, it comes with a trade-off in terms of space efficiency if maximizing GPU density is the priority. Especially in a large-scale AI deployment, liquid cooling is a way to go. The difference in GPU density becomes even more obvious when you start building a multi-rack cluster. All right, we have finally arrived at the last part of our GPU server overview, and this one is especially important for enterprise AI and private AI deployments, the NVIDIA RTX Pro 6000 Black Belt Server Edition PCIe GPU systems. In the enterprise market, especially at the edge data center level, customer needs it's not just the training large model, RAG, or fine-tuning. They also need to handle AI inferencing efficiently. And often that means deploying servers close to the source of the requests to reduce latency. To meet these needs, Supermicro has announced over 20 systems optimized for the new RTX Pro 6000 GPUs. This system accelerates enterprise AI deployment at the edge and significantly enhance performance across a wide range of workloads. Here are the key system families now shipping with the RTX Pro 6000 due to the same form factor and power consumption. With H200 PCIe, the server platforms are interchangeable for both H200 and RTX Pro 6000. They are totally the same as H200 PCIe GPU servers. To save time, I will pass the detail. Now that we have covered the key GPU systems, the servers, let's zoom out and take a data center level perspective. How do you take these powerful servers and actually design and build an AI-ready data center around them? If you have been following Supermicro, especially after this year's Computex, you have probably heard two acronyms floating around, DCBBS and DLC2. So what's the story behind them? And more importantly, how can they help us build and operate better data center? Let me give you a quick high-level overview of what they mean and why they matter. So what do they stand for? DCBBS is short for Data Center Building Block Solutions. And DLC2 stands for Direct Liquid Cooling Generation 2. Now, what exactly do these solutions offer? Let's start with DLC2. Most of you are probably familiar with the direct-to-chip liquid cooling. It's a method that uses liquid floating through the pipes to carry heat away from the high-power component like CPUs and GPUs. But if you have ever visited a liquid cooling data center, you might have noticed something surprising. It is still pretty noisy. Fans are still spinning. Why? That's because traditional direct-to-chip cooling only targets the major heat source, CPUs and GPUs. Other components still rely on fans for cooling. Supermicro's DLC2 changed that. It expands liquid cooling coverage to up to 98% of the server's heat-generating component, including CPU, GPU, PCIe switch, DIMMs, VRMs, power supplies, and more. Fewer fans means less noise. With DLC2, data center noise level can be reduced as low as 50 dB, but as quiet as the room I am in right now. Fewer fans also means less power consumption. In a traditional data center with PUE of 2.8, more than 40% of the total power goes to cooling, fans inside the server and air conditioning system. With DLC2, you can save up to 40% on the power cost, making your data center more efficient and sustainable. There's another innovation in DLC2, the use of the dry tower instead of traditional cooling tower. That might be not a huge issue in Southeast Asia, where water is generally abundant, but it is still worth mentioning. Traditional cooling towers rely on the evaporative cooling, where water is exposed to outdoor air to carry away the heat. Dry tower, on the other hand, use closed loop pipe and fine metal fans to transfer heat from the coolant to the outside air without water evaporation. This allows DLC2 to cool servers using water temperatures as high as 45 degrees Celsius and can reduce power consumption by up to 40%. And finally, compared to the air cooling DLC2, can save up to 60% of physical space, something we already touched on early when we discussed the server density. Now, let's talk about the reliability, which is especially critical when it comes to liquid cooling. Unlike air cooling, liquid in an IT environment is often seen as risky. Any leakage can be a serious issue. That's why Supermicro take extra steps to ensure the safety and reliability of our liquid cooled systems. All of our DLC2 racks are fully assembled at the factory, including cabling and liquid cooling pipes. We perform rigorous validation tests, both at our factory and again at customer side, to ensure everything remains intact during transportation and installation. Our management software doesn't just monitor the IT system, it also includes the full control over the liquid cooling infrastructure. You can remotely monitor and manage water temperature, flow rate, and other metrics, all from a centralized interface. Our in-rack CDU delivers up to 250 kilowatts of cooling capacity, far exceeding the typical 100 kilowatt CDUs found in the market. These help you maximize compute density per square meter. And this is designed with IT-grade reliability in mind, swappable pump, redundant pump support, and the touchscreen interface for real-time state monitoring. We have also invested heavily in customer co-play design for each component to ensure efficient heat transfer and optimal cooling performance. As for the cooling tower, we already covered that in the previous slide, and we will skip it here. One of the biggest difference between Supermicro and other server vendors is our ability to rapidly launch industry-leading new systems and the breadth of our portfolio. Just yesterday, I did a quick count. We currently have over 7,000 production-ready server models. That's a huge number. And it's possible because of our building block solution approach. Instead of designing each server from scratch, we use a set of modular in-house developed components, like Supermicro own motherboard, chassis, networking card, and more. Think of it just like a building with Lego blocks. We assemble these parts into complete system tailored to different workloads. And this concept does not stop at the server level. Installing the server into the rack, this is another building block. Combining the rack into a cluster, still a building block. Deploying cluster into a full data center, building block again. So today, Supermicro is going beyond just the server system. We are integrating switch, power shifts, CDUs, cooling towers, UPS, and more, bringing the building block philosophy to the data center level. Why? Because we understand that for our customer, time to operation is critical. The faster you can deploy, the faster you can deliver value. With Supermicro's DCBBS, you can go from concept to a full operational AI data center faster, more efficiently, and with great flexibility than ever before. One good reference is Elon Musk's XAI Colossus supercomputer with over 100,000 NVIDIA H100 GPUs. This multi-billion-dollar AI cluster is notable not just for its size, but also for the speed at which it was built. In only 122 days, Supermicro built this huge cluster. You can do some Google search after the webinar. We have a very beautiful video on YouTube. So DCBBS is not just a product, it's a system-level engineering approach. It starts early in the project planning phase, where Supermicro works closely with customers as a consultative partner. Our DCBBS team got involved from the very beginning, helping with data center floor plan design, power and water resources planning, cooling solution design, and overall project management. Once the infrastructure planning is complete, we move on to select the RAD L10 system and storage. These are the complete servers that include CPU, GPU, DIMM, networking card, SSD, and other components. From there, we use rack level building block to assemble these L10 systems into the rack. This is what we call L11. If the customer chooses liquid cooling, we then install the necessary liquid cooling component at the rack level. Next comes one of the most complex and critical steps, networking cabling, this including the connection of compute, storage, and management elements within the rack. And finally, we move into the on-site deployment phase, which includes the rack installation, cabling, OS and the software setup, validation and testing. This end-to-end process ensures that your AI data center is not only customized to your needs, but also ready to operate quickly and reliably. To support these rapid deployments and global scalability, Supermicro operates 4 major manufacturing hubs worldwide. Our headquarters factory in San Jose, California, right in the heart of Silicon Valley, a facility in the Netherlands serving the European markets, another 2 production centers in Asia, Taiwan, and Malaysia. Together, these sites give us a combined production capacity of up to 5,000 racks per month. This global footprint allows us to deliver fast, scale bigger, and support customer locally, whether you are building a small AI cluster or a full-scale AI factory. And it ties back to what we said earlier. In today's AI-driven world, time to operation is everything. With Supermicro, you are not just getting cutting-edge technology, you are getting the ability to deploy it quickly and reliably anywhere in the world. Okay, thanks for watching this webinar. I hope the Supermicro GPU servers and data center solutions I have introduced have left a good impression. Whenever you need any support, feel free to reach out to me. Thank you.
Thank you very much, Mr. Liang. Fantastic insight from Mr. Liang. I think our audience now has a much clearer pictures of how Supermicro is shaping the futures of computer workload. So next, we're gonna move to the Q&A sessions. Yes. So, all right. Now it is your turn. Let's open the floor for Q&A. Drop your questions in the chat or Q&A box, and I will direct them to our speakers. Don't be shy. This is a chance to tap into the knowledge of the of 2 experts who live and breathe these technologies. So if anyone don't have a question, just write them down into the chat box, and I will address the question to Mr. Chen and Mr. Liang.
For the way to compare between the 8U liquid cooling and 10U air cooled, I think is significantly, and you can check the detail of weight information on our website, because we have different skills for the 8U liquid cooling and 10U air cooled. Remember that in the 10U air cooled server, the heaviest parts is the heat sink. It's all metal. Yeah. So it's take a very, very big weight in the server. So I advise you to check our website. Just select this, the product and then GPU server, and you will find more detail of each servers. I'm not sure if I answered your question.
So thank you. Anyone have any more questions? So if no more questions, we can move to the closing remarks. We have reached the end of our sessions, and what an insightful hours it is. Been a big thank to our speakers, Mr. Wen Yu Chen and Mr. Si Liang, for sharing your expertise, and to all of you for taking the time to join us today. Before the session is ending, I have something exciting to share. Our next PSTC Academy webinar is coming very soon, next month, on the topic of what is artificial intelligence in business on September 4th, 2025. It is very important because like the AI is our futures. This is a now and moving forward to our futures. If you find this interesting, you can register with the PSTC site on Facebook or on the LinkedIn. We will be joined by two incredible speakers, Mr. Sutipan Sutatnayutaya, Chief Product Officer of LegTech company, and Assistant Professors Dr. Shanwit Bunchoi, President of the Artificial Intelligence Entrepreneur Associations of Thailand. They will be explore how AI is transforming businesses, unlocking opportunities, and shaping the futures of work. If you guys find this one is interesting, you can register with you can go to the site of PSTC, say on Facebook site, or even the LinkedIn site. Or if you struggling how to find the site, you can contact one of our teams to get some more informations. So if you guys don't have any more questions, thank you very much for today's sessions. Thank you, Mr. Shen, and thank you for Mr. Liang for your expertise and for your informations. Thank you very much, everyone.
Thank you.
Thank you. Thank you.
Thank you so much.
Thank you.